how the cell get what they needed. And to answer that question, this rely on the cell membrane. So a cell membrane control the passage or the movement of substances in and outside of the cell. But some question came to our mind: how things being controlled? Why there is substances that get into any type of cells? Why there is substances that get into certain type of cells? Why there are substances that are not allowed to get into the cell? Why some substances which are get out of the cell will not allowed to come back into the cells? And all this rely on the cell membrane. Cell membrane, as you know, chemically made of a bilayer of phospholipids which is structure like the follow. This is a phospholipid. The head here is a phosphate group, and the tail here is a lipid. So we have a bilayer, that means we have a layer, and we have another layer which is facing this one. And the second structure that found in the structure of the cell membrane is the protein. So the chemical and the physical characteristic of the phospholipid allow only certain substances to pass through them directly. So very small substances like oxygen, or very small, which are big or they are not dissolving in lipids, they should pass through the protein channels. Okay? So based on this chemical structure, we know how the cell membrane controls passages of substances in and outside of the cell. So what are the processes by which these substances get in or get out? So first of all, let's list the particle or substances that get inside of the cell and some that get out of the cells. So substances will be like glucose. Every cell needs a glucose to do a cellular respiration. Amino acids. Every cell needs amino acids to build their own protein that they need for their activities. Oxygen. Also cells need oxygen to carry out a cellular respiration by breaking down or burning down this glucose. Water and minerals or salt. And lipids and some product that may come specifically of a certain type of cells. So these are something that, or are the substances that must get in of the cell. Substances that must get out will be carbon dioxide, and the other substance that will get out will be a waste product. Such as ammonia or urea or something like that. And maybe this cells is secreting a product. And then excess of water, if the water is increased, then the normal limit should leave. And excess of salts. So this substance that must get inside of the cell, and this substance must get out of the cells. So this substance is moved by one of the following. processes: diffusion and osmosis and active transport. Diffusion, you imagine in the normal daily life when we add sugar to our tea. So here, after a while, the taste of the water, which is tasteless, will become a sugary or sweet. And this actually came from the fact that the particle of the sugar will diffuse between the particle of the water. So according to or due to the diffusion process, which spreading of this particle from the area of the high concentration to area of the low concentration until they are distributed all over the solution of the water, and that's why we feel a tasty water or the tea. The tea itself is particles of the tea which is spread between the particle of the water also make the water color become a red, and you know that the original color of the water is colorless. So why the color of the water became red? Because due to the spreading of the particle of the tea between the particle of the water. Okay, so this is a very simple example of the diffusion process. And so now in glucose outside of the cell, and amino acid and oxygen outside of the cells, they are in high concentration. Definitely they will diffuse through the cell membrane into the cell. Some of these substances like oxygen will diffuse directly through the bilayer of phospholipids, and the other, which are like glucose and amino acids, which are big, so they will move through the protein channels. In other hands, water, although they are small, but because they are hydrophilic, so they will not dissolve in lipids. And you know that here the bilayer of phospholipids is made mainly of lipids, so they will not pass directly through the bilayer of phospholipids, so they will move through the protein channel. And actually water moves by osmosis. Osmosis is a type of diffusion, but only concerned with the water. It's not concerned with any other substances other than water. And also here is governed by the concentration of the water molecules. Imagine, for example, if we have 2 cups. Of the same size, this may be of cup number 1 and this may be of cup number 2. Imagine those, they are of the same size and filled with water to the same level. So if we add a salt for cup number 2, what do you think about the amount of the water after I add salt to the cup number 2? So you have 3 options here. Well, the option 1, will the water amount will be higher in the cup number 1, or option 2 will be higher in the cup number 2, or it will be the same. Before you answer this, back to the chemical equation or the chemical reaction that will be happen between the water and the salt. So you know that chemically salt is NaCl, sodium chloride, and water is H2O. So this chemical reaction result in the following. We will have NaOH, sodium hydroxide, and HCl, hydrochloric acid. That means against each molecule of sodium chloride, we have a molecule of water will be broken down. That means the more salt in the water will be the less water molecule. And the less salt in the water, that means will be the more water molecules. So our cells are surrounded by three types of solution based on the concentration of the solute which is dissolving in the water. So if we imagine here, this is our cell. You know that the cytoplasm contains water. So here, if you imagine that the amount of water in the cytoplasm is like 90%, and the amount of the dissolved solute in the water is about 10%. Then we have three types of solutions. The first solution is about 79% water and 3% is a salt. The second one is about 90% water and 10% is a salt. And the third solution is about like 80% water and 20% is salt. If you compare the solution here to the solution of the cell sap, this contains less and this contains equal amount of salt, and this contains more amount of salt. Okay, the solute, the concentration of solute refers to the word tonicity. So these solutions will end with suffix tonic. So we have a term that used as a prefix indicate higher or lower or equal, and this, like here we have a less solute, so here we could use a prefix hypo, because hypo means low, because this is have a less solute or than the cell sap. That means the water here is higher. And this is a suffix iso, because iso means equal. And this is here use a prefix hyper, because hyper means higher. So the prefix here is iso, and the prefix here is hypo, and the prefix here is hyper. So now, if this cell is exposed to any one of those, the movement of water will be according to which one it is exposed to. So if it is exposed to the hypotonic solution, and we said that osmosis is movement of water from the area where they are highly concentrated, the area where they are low concentrated, through semi-permeable membrane. So here, based on the osmosis, the water will enter into the cell. And this will result in the swelling of the cell. If we put the cell in the isotonic solution, in this situation, the water will move in both directions. So the net movement of the water will be zero. And here, no change will happen to the shape of the cell. So because the water, the cell, gain water and lost the water at the same time. And in the cell solution, actually, the water content is higher than in the cell than in the solution. So the water will leave from the solution into the cell, and this will result in shrinkage. The cell here will shrink. And this is actually explain how the water in our body move into our cells, or how our body lost, or the cell in our body lost the water. So let's have a break, and then after that we continue with the active transportation.